Hello and welcome to our tower training exercise. If you want, you can pause the video and take a look here at some of the instructions. But let's now go to the cover page. So here in the cover page, you'll find some basic information such as date, version, project timeline, project roles defined, and so on. So this is something that is usually filled out at the start of the engagement. Now let's move on to work product mapping. So these are the work products from the standard ISO SC 21434, together with some descriptions and also requirements from the standard. And here are the assigned tabs that are presented here below. Now let's move on to assumptions. Here, as mentioned, we have some security assumptions about the operational environment and also the higher level of the system integrating this component and assumptions about the target of evaluation. These assumptions are considered during the risk analysis to justify why certain risks may be accepted. The main part that I want to draw your attention to is the system item architecture that we're going to be working with here. So here we have something such as the Windows switch controller. If you take a closer look at the architecture, in the very middle we have a cabin controller. On this side, we have a button panel driver and the button panel passenger. On this side, we have the door ECU left and door ECU right, and each of them are connected to an actuator. And here we have a CVM. And also, you may notice that here it is written system boundary. Also, you may want to pay attention to some of the cables that are mentioned here. If you want, you can, as always, pause the video and analyze the system architecture in more detail. So what we'll be doing is basically going through the different steps of the tower process and filling out these tables together. We will not necessarily fill out all of the rows presented here, as you may do that yourself if you want to. But we will give you a good understanding on how to make decisions and fill out the tables yourselves. So let's get into it and start with item definition. So under function ID, we have F001, F002, and F003. So as always, we can go back to architecture. And just a side note, you can always contact any of the engineers if you have any questions about any of the components. So once again, let's take a closer look at the Windows switch controller and think about some of the function names that we can come up with. As an example, I'll start. The very first can be named open position. So if we have open position, what is another example you can think of? Another example is the opposite, closed position. And perhaps you might be able to come up with another function name, perhaps something in between an open and closed position. In this case, we have neutral position. Let's try and think of some of the function descriptions. So once again, the function ID is F001, function name open position, and then we have function description. I'll start by giving an example. An example can be driver and passenger window shall be opened or closed by actuators controlled by switch levers. Now try and think of what you would put here for closed position. So if you want, we can go back for a second to the architecture. Once again, we have door ECU left, door ECU right, and we have actuators. And here we're talking about an open position and closed position. So in this case, it only makes sense to have the same answer. Driver and passenger window shall be opened or closed by actuators controlled by switch levers. So what about neutral position? Does it make sense to also put the same function description here? The correct answer is yes. Now let's take a look at this table. So here we have component ID and component name. So let's start filling out this section. As always, I suggest going back to this system item architecture overview and start listing out the component names. Let's start by writing button panel driver. Then what do we have next? The next one that we can list is button panel passenger. Then we could list cabin controller. Next up, going once again from this side to this one, we could write door ECU left and door ECU right. And then we have CVM. Now let's focus on descriptions. Let's try and come up with a description for button panel driver. Once again, I suggest referencing the system item architecture. You could start with listing what you see here. So, for example, you could write something such as control panel located on the driver's side, used to operate various functions, including window control and door locks. So let's see if this makes sense. Control panel located on the driver's side, used to operate various functions, including window control and door locks. Let's go back and take a look at this image again. So now try and think of a description for the button panel passenger. Once again, you can basically start listing out what you see here. So in this case, we could write something similar, such as control panel located on the passenger's side, used to operate functions such as window control. Once again, let's check if this makes sense. And also notice the difference how under button panel driver we mention window control and door locks, and under button panel passenger we just mention used to operate functions such as window control. Now let's focus on cabin controller and try to create a description. We could do something as simple as writing located in a box close to the passenger's feet. Next up, we have door ECU left. Once again, I best suggest for you to write down your answer and try to think of a description for yourself and then check together with me. It doesn't need to be exactly the same. It can be worded differently, it could be different, as long as it makes sense. So in this case, we can write something like door ECUs have EEPROM plus time model to memorize Windows position, as well as door ECUs have actuator current monitoring. Now, what about door ECU write? Does it make sense to include the same description as we have here? The answer would be yes. Now all that we have left is the CVM. And once again, as a reminder, don't forget to take a look at the cables here. For CVM, let's write down something like cabin vehicle manager DCAN network for the cabin controller has external access points located outside the car body for diagnostics or updates. Once again, if you want, you can pause the video here and take a look also at the system architecture here and try and understand how all of this makes sense. If you want, you can pause the video here, try and understand how all of this makes sense. Now let's move on to the table below here. So under component 1, we can list button panel driver. Here under component 2, we can write cabin controller. Under name, we can define open window. We can leave the description off, or if you want, you can add the description here. But in this case, I want to expand a bit here and write down the description in more details. So this channel connects the button panel driver to the cabin controller to enable window control. The system uses pin cables to transmit analog signals representing up and down or none. Also, these signals are interpreted by the cabin controller to adjust the Windows position accordingly. Okay, let's make this easier for you to see. And under technology, we can mention pin cable analog. Next up, we can leave some of these rows blank and focus here. So under name, we will write close window. Sorry, I keep making typing mistakes. So once again, if we have open window position here and we have closed window position here, once again, does it make sense to include the same description here? And once again, it does. And that's what we're gonna do. Then once again, we must include neutral position here and provide a description here. So pin cables have two signals which are up or down. Or in this case, we should also include none. Now let's go back here and enter some of the other components. So other components that we have not written down here yet are button, panel, passenger, as well as cabin controller. Once again, cabin controller, because we have it connected to door ECU left and door ECU right, and CVM. So accordingly, since we have component 1, here we have component 2. So if we take a look at button, panel, passenger, we have the cabin controller. So let's list it out here. If we take a look at cabin controller, once again, as mentioned, we have door ECU left and door ECU right. So that's what we're gonna have to write down here. Door ECU left and door ECU right. And if we take a look at CVM, we have cabin controller. And also you can take some time to list all of the technologies here. So the same way as we have the pin cable listed here, we can take a look at what we have here. So in this case, we would write pin cable again. So let's just copy. So try and think for yourself what should be the correct answers in these 3 rows. So once again, we have cabin controller and door ECU left. Then we have cabin controller and door ECU right. And then we have CVM and cabin controller. So accordingly, we should have LIN, and CAN. Now that we have all of these sections filled out here, which is once again one of the most important parts of Tara, item definition, which is where we start and where almost the rest of our work is decided for us if we do this part correctly. Now let's move on to impact rating from each damage scenario for targeted assets. Here we have to describe the consequence. Targeted assets, provide asset IDs, select a targeted security property from confidentiality, integrity, availability, authentication, authorization, or accounting. Select the correct impacted stakeholder, which is either the road user, OEM, or supplier. Then we have the SFOP approach. So we have to select either severe, major, moderate, or negligible, and the same applies for all of these cases. Then we have the final impact rating and rating justification. So in case you get confused about these definitions or about the SFOP model, you can always go back to the training course and refer to some of the material that we have previously discussed. But also, just to give you a short overview, we can go to this page here and briefly take a look at some of the criteria that we'll be using for evaluation. So once again, we're going to be using severe, major, moderate, or negligible as impact ratings. And here you can once again take a brief look to remember the criteria to better be able to provide the most accurate evaluation in selecting either severe, major, moderate, or negligible. Now let's go back. So first we can write down the targeted assets. So let's start with cabin controller. Next up, let's write CVM, then door ECU left, then door ECU write. Then, if you remember, we have the button panel driver, as well as the button panel passenger, together with an actuator. Let's start by describing the consequence. So I'll start first by giving you an example. So once again, we're talking about the cabin controller, right? So think about what it does and think about the potential consequences. One example can be window is opened and unable to be closed. Now let's take a look at CVM and try to think of a possible consequence. You can simply start by thinking about its functionalities and the potential consequences. An example of such could be unable to close or open windows with key fob. Now we have door ECU left and door ECU right. So once again, try to think about what they do and the possible consequences. So for door ECU left, we could write down something such as window opens or closes without the input of the driver or passenger. Now what about door ECU right? One example could be window continues closing past adequate resistance. Next up, we have button panel driver. So I suggest to take a few moments for yourself and try to come up with some possible descriptions for the consequence. Imagine an example where the functionality is behaving in a correct way and basically doing the opposite of what you want it to do. An example of such could be open function closes and closing function opens. Then we have button panel passenger. Now try and think of a similar situation where the functionality doesn't work how you want it to do, but in this case it was doing the opposite of what we wanted to do, but in this case it doesn't even perform the action that we want it to. Meaning that the button does not open nor close the window. And then we have the actuator. In this case, the functionality not only doesn't act as we want it to, it's generally speaking inoperable, meaning that the window is unable to open or close. Even though we've listed some of the main targeted assets, we could actually write door ECU left here again and think of another description for the consequence. This might sound a bit more tricky or more technical, but an example would be overload causes ECU to reset, meaning that it's losing window position memory. Now that we have listed out the descriptions for the consequences and we have the targeted assets, we can of course include some of the asset IDs. You can fill out the rest of them yourself. So here we have C003, C, here we have C004, and so on. Now let's start with our targeted security property. So we have to choose from confidentiality, integrity, availability, authentication, authorization, or accounting. If you take a look again at the description, it says window is opened and unable to be closed, meaning there is a lack of integrity going on. Then what about the impacted stakeholder? We have to choose from the road user, OEM, or supplier. So in this case, it would be a road user. Now let's move on to the individual impact type and rating. So starting with safety. Here we says that the window is opened and unable to be closed, meaning there is no threat to our safety, so we can put negligible. Then what about financial? In this case, we could potentially put either major or moderate. So what we can do is go back here for a second and look at the criteria for financial. So if we were to put, let's say, moderate, let's take a look at the description for a bit. The financial damage leads to inconvenient consequences which the affected road user will be able to overcome with limited resources. While under major it says the financial damage leads to substantial consequences which the affected road user will be able to overcome. Well, in this case, we're just talking about a window that's not operating the way it should be, so we could easily put moderate. Then what about operational? Operational is a bit different. So once again, if we go back here and take a look at operational, and let's take a look at the impact rating for major. The operational damage leads to the loss or impairment of an important vehicle function, significant annoyance of the driver. So I believe in this case we can put major. Then in terms of privacy, there is no data breach going on, there's no exposure of our personally identifiable information going on, so we can easily put negligible. And as for the final impact rating, we can also put major. So now let's move on to a bit of a different example than the second one. Let's move on to this one. So here it says window opens or closes without the input of the driver or passenger. So for the targeted security property, we can once again put integrity. Then for the impacted stakeholder, we can once again put road user. But what about safety in this case? Because once again, the window opens or closes without any input from the driver or passenger himself. So in this case, we could definitely select moderate. Moderate means that there may be some light and moderate injuries. Because if the window continues closing or opening however it wants, there might be some harm or damage done to health. Then in terms of financial, we could put major, because under major it says the financial damage leads to substantial consequences which the affected road user will be able to overcome. So having the window go up or down by itself means that there are some deeper underlying issues. Then for operational, we could once again put major, and for privacy we have negligible. So what would the final impact rating be? The answer would be major. Now the second row that I want to fill out together is this one. So Here it says, window continues closing past adequate resistance. So what about targeted security property? Here we could write, once again, integrity. The impacted stakeholder is, once again, the road user. Then, what about safety? I really want to focus your attention here, because for safety, we're gonna put severe. Imagine sticking out your arm or your finger outside of the window and it still continues closing past adequate resistance. So this is definitely a case of severe for safety. Now under financial, we could go ahead and once again list moderate. For operational, we could even go as high as listing severe. Let's take a look here. The operational damage leads to the loss or impairment of a core vehicle function, which is exactly the case here. Then for privacy, we can once again put negligible, and the final impact rating here would be severe. Now what I want you to do is pause the video right here and then fill out the rest of the table yourself and then check together with me. I hope you have filled all of these out, and starting with the site, if you got the final impact ratings correctly, I would say you are already on the right path and congratulations. So I would recommend for you to once again pause the video and check your answers here. Also, if you have put negligible for privacy for each of these cases, you are also correct, because in neither of these cases we are having any of our personal information being exposed. So first of all, I hope you remember the difference between a threat scenario, an attack path, and damage scenario. If you don't remember the differences between these three, I once again highly suggest for you to go back to the training course and review each of them. So let's start with filling out the threat scenario section here. Of course, if you want, you can fill out the whole table yourself and then check together with me. And as a reminder, our answers don't need to be exact. So I'll start by giving an example here. So under threat scenario, we could write something like cabin controller is reflashed with new firmware plus our software via incorrect means. So once again, we're not going into details about how this type of attack was accomplished, like providing step-by-step instructions. And we're not talking about the damage of this type of attack, we're just providing a threat scenario. And also, if you want, you can provide a more in-depth threat scenario description here, and it's marked optional, but I'll give you an example. So an attacker gains access to the vehicles to port using port or update interface using unauthorized tools to reflash the cabin controller with tampered. So as you can see, we have provided some more details, but of course still possible to dive even deeper into the technical details. But here is a high-level overview of a threat scenario description. Now we have to choose the threat type. So here we have something that we talked during our training. So STRIDE, something such as the STRIDE framework. So we have to choose either spoofing, tampering, repudiation, information disclosure, denial of service, or elevation of privilege. So once again, let's read through the threat scenario. Cabin controller is reflashed with new firmware software via incorrect means. Also, an attacker gains access to the vehicle's OBD2 port or update interface using unauthorized tools to reflash the cabin controller with tampered firmware. This seems like a definite case of tampering. You can also go back to some of the tables that we previously filled out and provide the asset ID. So in this case, it would be C003. And we can also provide the damage scenario ID, which would be DS001. Now let's provide an attack path description. So once again, an attack path is like a detailed explanation of the step-by-step process. So I'll start by giving an example here. An attacker gains access to the vehicle's OBD2 port or update interface using unauthorized tools to reflash the cabin controller with tampered firmware. So here we have our attack path. Now what we're gonna do is choose the correct attack potential parameters, starting with elapsed time, specialist expertise, knowledge of item or component, window of opportunity, equipment, and then we will provide the attack visibility value and the attack visibility rating. So let's start by looking at elapsed time, and these are the 5 parameters that we can choose from. So in this case, I suggest looking at the threat scenario, or even better, focusing on attack path description. But, as we discussed during the training, it's best to leave elapsed time for last, as when you have all of the other attack potential parameters filled out, it's easiest to then select the appropriate elapsed time parameter. So let's start instead with specialist expertise. So take a look once again at the attack path description, as it provides us most details. So an attacker gains access to the vehicle's OBD2 port or update interface using unauthorized tools to reflash the cabin controller with tampered firmware. So under specialist expertise, we can choose from layman, proficient, expert, or multiple experts. In this case, we could select expert, as it requires quite a high level of understanding on how to implement some of these actions, such as knowing that you can access the vehicle's OBD port, and it's also mentioned using unauthorized tools, and also you need to have knowledge on how to reflash the cabin controller and tamper with firmware. In this case, expert is the appropriate answer. What about knowledge of item component? We have to choose from public, restricted, confidential, or strictly confidential. The steps provided here are, in a sense, oddly specific. You have to have a very good understanding on, of course, how to perform these actions and also where to perform these actions. So in this case, we could apply strictly confidential. Then under window of opportunity, we have to choose unlimited, easy, moderate, or difficult, none. So since here we have a mention of the vehicle's OBD port or update interface, this means that we have to have some level of physical access. In this case, we would need to select moderate. Then we have equipment. We can choose from standard, specialized, bespoke, or multiple bespoke. If you notice here, it's mentioned unauthorized tools. We'll also be talking about tampering and reflashing firmware and so on. So in this case, it would make sense to choose bespoke. Then let's take a look at our final parameter here, which is elapsed time. So combined with the level of expertise that we need, the knowledge of the item, the window of opportunity, and equipment required, we could easily select around 6 months. Now by adding all of these together, the final sum would make up 45. And the final attack feasibility rating would be considered very low. If, in case you have forgotten how to evaluate attack feasibility rating, we could take a look here. Here we have the attack feasibility rating, and here we have the values, and if the value is above 25, it is considered very low. So, such as we have selected here. Now let's try and do this a bit differently. Let's try and establish another fit scenario. I will once again help out with this. So let's start by saying ECU memory is messed with in real time, causing incorrect and continued output. Then I'm gonna skip here and provide an attack path description. You can once again, as always, pause the video right this moment and think of an attack path description for yourself. I'm gonna start by writing one down. An attacker gains access to the vehicle's ECU via a compromised diagnostic tool or malware. They then inject malicious code that alters the ECU's memory in real time, causing it to generate incorrect outputs continuously. Now, another thing that we can do is select the threat type together. So once again, we have to choose the correct answer from these ones. So ECU memory is messed with in real time, causing incorrect and continued output. So this once again seems like a definitive case of tampering. We can once again list the asset IDs and the damage scenario IDs. So this case we have C004 and here we have DS004. So what I want you to do is take some time for yourself and fill out all of these. And then after I'm finished saying the sentence, you will be able to see the correct answers filled out, and hopefully you will be able to check them with me. So let's see how well you did. So if under attack feasibility rating you selected very low, that means you are already on the correct path. And if you got the attack feasibility value somewhere close to 41, then you also did pretty well. So let's start by looking at specialist expertise. So in this case, we have once again also selected expert, as in the previous example that we went through together. Then in terms of knowledge of item component, we have confidential, because if we take a look at the attack path description again, it says an attacker gains access to the vehicle's ECU via compromised diagnostic tool or malware. They then inject malicious code that alters the ECU's memory in real time, causing it to generate incorrect outputs continuously. This means that there is some level of confidentiality relating to the information that the attacker must have to be able to accomplish these steps, but it's not strictly confidential as we had in the previous example. Now, under window of opportunity, if you selected moderate, then it's correct, because once again we have some level of restrictions because we have to firstly get access to the ECU. Then Under equipment, if you selected bespoke, then you're correct because we have to have some kind of higher level of more specialized equipment. So once again, the attack visibility value is 41 and the attack visibility rating is very low. Now let's instead fill out the final row here and come up with a threat scenario. Let's write something such as, can signals from CVM are spoofed and requesting the window to be closed indefinitely. Now we can once again go and define the attack path description. So as always, I recommend for you to pause the video and do this step yourself. So here I'm gonna write an attacker intercepts and spoofs can signals from the CVM continuously sending commands that request the vehicle's window to close indefinitely. Now let's take a look at the threat type. Once again, choose the correct answer. The threat scenario is can signals from CVM are spoofed and requesting the window to be closed indefinitely. So it's once again a definitive case of spoofing. Now we can once again write the asset ID and the damage scenario ID. So let's go back and do that. So here it should be C006 and damage scenario 003. Now let's try and do the same. I want you to pause this video and fill out these sections yourself and then check them together in a moment. So I hope you have already filled out the attack potential parameters and we can go ahead and check the answers together. So let's start again with specialist expertise. Just to recap a bit, let's take a look at the attack path description briefly. An attacker intercepts and spoofs scan signals from the CVM, continuously sending commands that request the vehicle's window to close indefinitely. So in this case, we have put expert. Then under knowledge of item or component, we have even put restricted. Because the attacker is able to intercept and even spoof the signals. And once again, if you remember what spoofing stands for, it means pretending to be something or someone other than yourself. So in this case, we have restricted. Then what about window of opportunity? In this case, we have put moderate because once again, we have some level of access and also some levels of restrictions. And under equipment, we have specialized. However, if we take a look at elapsed time, the ability to generally successfully exploit the attack from start to finish would take only around a month. So the final attack visibility rating would be medium, and the attack visibility value in this case would be 19. As always, in case you have any questions about any of these values, feel free to contact us or go back to some of the training slides or videos and take a look at some of the values that we have provided here and their descriptions. Now let's move on to risk determination treatment. So what we're going to do is just fill in a few rows of examples. So this time I want to actually start with threat scenario 2 and also fill in threat scenario 3. So that's what we're going to do. So I'll start by providing the risk treatment decision justification. So we could write something such as the scenario involves the risk of an ECU memory being tampered with in real time, leading to incorrect and potentially ongoing system outputs. This type of risk can have serious consequences, including system failures, safety issues, or operational disruptions. Okay, let's read through the whole thing again. This scenario involves the risk of an ECU memory being tampered with in real time, leading to incorrect and potentially ongoing system outputs. This type of risk can have serious consequences, including system failures, safety issues, or operational disruptions. So as for risk treatment decision, we can put reducing the risk. For the risk value, we can provide number 2. And as for residual risk, we would put number 1. Now let's fill in this row talking about threat scenario number 3. So here, let's write down something such as implementing cryptographic methods for authenticating CAN signals between the CVM and window controller to prevent spoofing for signal authentication. Now, once again, as for the risk treatment decision, we can once again put reducing the risk, and the risk value here is actually number 3. And as for residual risk, we have once again number 1. So as always, I suggest for you to fill out the rest of the table here yourself. Now let's move on to the final step of this tower training video, which is tower review. The goal of this section is to make sure that each requirement is done accurately. This is also important to look at when you want to reuse a Tara, and you can utilize a similar checklist with custom questions specific to changes to the architecture. So if you want, you can also take some time to fill out all of these, but this page is meant to be included just as a reference for you to check that everything has been ticked and everything has been checked and everything has been done correctly. So here below we also have questions for review, for example, such as have damage scenarios been identified in compliance with requirement 15.01? Or have attack paths been identified based on requirement 15.8 and requirement 15.9, and so on. So I also highly suggest for you to go through each of these and make sure for yourself that everything has been filled out to the maximum and in high quality. So thank you for staying together for the duration of this exercise.